Hello, I hope you are well. Today I'm going to solve some of the questions in assignment 10. You can see Canvas assignment 10 is uploaded. There are 40 questions on that. I'm going to solve some of the odd numbered ones, and you are going to submit some of the even numbered ones as your next quiz. So for example, I will solve questions 1, 3, 5 like this, and you will solve some of the even numbers one like 2, 4, 6. I'm going to explain more on this later in Canvas. The definition of Taylor polynomial is repeated here. This is from the lecture notes. You know, if you want to write up to term of nth degree or nth order, Pn is f of a. We need f of a. A is the center, so this is the evaluation or finding the Taylor polynomial of f at x equals a. So a is the center. We need f of a. We need f prime of a. We need the second derivative of f at a, and we keep going on until the nth derivative of f at point a. The rest is very easy. N factorial is just a number, x minus a, we know a, so the rest is very simple. Let's start with question 1. In this question we are going to find the Taylor polynomials for these f's given at the given a's. Question 1, f is e to the power of 2x. If you remember, we found the Taylor series of e to the power of x. We can use that, replace x with 2x, or we can start from scratch. That's what we are going to do now, and find the Taylor polynomial of order 0, 1, 2, and 3. We need a center. The center in this question is given at 0, so it's a Maclaurin series. We have f. We need the derivative. Why do we need the derivative? Look at here, because here f prime of a is necessary, and also second order is necessary, and also the third one. So because we are going to go up to p3 in these sets of questions. F prime of e to the power of 2x is easily found. It's 2 times e to the power of 2x. We also need the second derivative. It's extremely simple. You just multiply that by this 2. 2 times 2 is 4, and e to the power of 2x. We might need the third one. It's easily 8e to the power of 2x. Okay, we need to evaluate these at 0 because the center is 0. Here we need f of a, so we need f at the center. Center is 0 in this example, so what we need is f of 0. F of 0 is f of x is e to the power of 2x, so f of 0 is e to the power of 2 times 0, which is e to the power of 0, which is 1. We also need f prime at 0. You can see f prime is 2e to the power of 2x. So here it's 2 times 1, which is 2. Similarly, the second derivative at 0 is 4. 4 times e to the power of 0. E to the power of 0 is 1. 4 times 1 is 4. We need the third derivative of f at 0, which is 8 times e to the power of 0. 8 times 1 which is 8. Okay, since we want to go up to P3, we stop here. We don't want to keep going. We can keep going. We can add many terms. But in this example, in this practice questions, I want to stop at 3. So that's it. We have it. If you want to write P0 or the zero order Taylor polynomial, you can see when P is 0, we just have the first term, which is f of 0. So P0 is 1 because f of 0 is 1. If you want to write P1, you can see here P1 has the second term too, so it's 1 plus f prime at 0. F prime at 0 is 2, so we will have 2 times x minus a. A is 0, so we have just x here. 1 plus 2x. This is the line that approximates e to the power of 2x around the center 0. Let me write 2 more Taylor polynomials. If you want P2, this is the second order Taylor polynomial of e to the power of 2x at a0. You can see we have f of a, which is 1. We have f prime of 0 at times x minus 0, which is 2x. So everything is like the previous Taylor polynomial. Now we have a new term. We have this term, the second order of f at 0. The second derivative of f at 0 is 4. But we should divide 4 by 2 factorial. 2 factorial is 2. What else? We have x minus a to the power of 2. A is 0, so we have x to the power of 2. Or you can write this as 1 plus 2x plus 2x2. Finally, I'm going to write P3 too, same as above. I don't repeat everything. We just need to add a new term. So this new term would be the third derivative of f at 0, which is 8. Divided by 3 factorial. 3 factorial is 6. Because it's k factorial. When k is 3, we have second derivative of f at a, which is 8, divided by 3 factorial, which is 6, times x minus a to the power of 3. A is 0, so we have x to the power of 3. That's it. Very simple. Let's go to question 3. In question 3, we have f of x as ln of x and a is 1. I go faster this time because you learned how it works. We need, after having f of x, we need to find f prime. Again, everything is like the previous example. The only difference is a is here 1 and f is ln instead of e to the power of 2x. We need f prime. F prime of ln is 1 over x. We also need the second derivative of f at x. All of you know how to find this. It's minus 1 over x squared. If you don't remember how to find the derivatives, review your notes of 172. We also need the third derivative. So one more derivative, we have 2 over x to the power of 3. We need to evaluate this at a. So we start from, let me choose another color for this part. So we start from the first one, f of 1. F of 1 is ln of 1, which is 0. Then we find f prime at 1, which is 1 over 1, which is 1. And we need the second derivative at 1. It's minus 1 over 1 to the power of 2, which is negative 1. And finally, this third derivative is 2 to the power of 2 over 1 to the power of 3, which is 2. So we have all these terms we have f of a, f prime of a, the second derivative of f at a, and the third derivative of f at a. We can easily write the Taylor polynomials. Again, like before, p0 or p0 is simply f of 1, which is 0. p1 is zero. I don't repeat to 0. What is the next term? We need to have, let's look at here. The next term is f prime at a. F prime at a is 1, so we have 1. So I write it 0 plus 1 times what? 1 times x minus a. A is 1. So it's 1 times x minus 1, which is x minus 1. When we want to write p2, we write p1, and then we add the new term. The new term is the derivative. So let me put this in brackets so that you don't confuse. We need the derivative, the second derivative of f at 1, which is minus 1, over 2 factorial, which is 2, times x minus a. X minus a is 1, so it's x minus 1 to the power of 2. That's it. You can see it's very simple. You cannot make mistake with Taylor series. It's very simple. Just pay attention to the equation which will be given to you. Things are changing so fast. I'm recording this video on the 20th of March 2020. At this moment, the plan is to have your final exam as a Canvas quiz, which you have like a day to start and end in a few minutes. I don't know how the details work, so we are still discussing this. As you have seen, things are changing so fast, but I will update you when it's confirmed how the exam will be. I will update you. You don't need to worry, just relax, but study. It doesn't mean you shouldn't study. I have been following the number of views on YouTube videos. I have noticed many of you are not watching them. Please keep watching them and follow. You will forget everything if you don't study. Okay, let's go back. We want to write P3. We have P2. P2 is this. The next term we need to add is the third derivative of f at a. So this is at 1. The third derivative of f at a, which is 2. So we have plus 2 divided by 3 factorial, which is 6, times x minus a is 1, to the power of 3. In the previous two examples, we we found the Taylor polynomials of order 0, 1, 2, and 3. Now I'm going to solve a question from the second section of assignment 10, which is finding the Maclaurin series or finding the Taylor series at x equals 0. So in these questions, we don't want to find Taylor polynomials. Taylor polynomial is limited. We just found, for example, look at here, we found just a few terms. Or here we have found 1, 2, 3, 4 terms, and then that's it. When you are asked to find the Maclaurin series or Taylor series, not polynomials, you need to find infinite terms. So we need to write infinite terms of these Taylor series. That's why it's called Taylor series. It's a series. It's infinite series. Taylor polynomial is a polynomial. It's limited. It's not infinite. So I'm going to solve question 11, for example. Yes, question 11 is good. Question 11 from your assignment 10, which is e to the power of minus x. Here, I repeat, I want to find the Taylor series at x equals 0 or the Maclaurin series. So I need infinite terms. Just having 1 term, 2 term, 3 term, 4 term is not enough. So I need to write a general term for the derivatives. So I need to write the k derivative because we need the k derivative to write the Taylor series. Please refer to the definition of Taylor series or Maclaurin series in the beginning of the lecture notes related to that topic. Okay, so let me again write f and its derivative. F is e to the power of minus x. The derivative of f is negative e to the power of negative x. The second derivative of f is what? Negative, which is positive e to the power of negative x. I think you are getting the trend. The third derivative is negative e to the power of negative x. So can you tell me how we can write the k derivative of f at x? You can pause the video, think about this, try to write the general term for the case derivative of f of x. Okay, I'm sure all of you could find it. The result is negative 1 to the power of k e to the power of negative x. Okay, we are finding the Maclaurin series. So for Maclaurin series, I hope I spell it correctly. Maclaurin series, x is 0. So we are going to find everything at x equals 0. So we have f of 0, which is e to the power of negative 0. So let me write it, e to the power of negative 0, which is 1. The second derivative, the first derivative at 0 is minus e to the power of minus 0, which is negative 1. You got it. The rest is very easy. The second derivative at 0 is e to the power of negative 0, which is 1. So in general term, the k derivative of f at 0 is minus 1 to the power of k times e to the power of 0, which is 1. So therefore we have minus 1 to the power of k. So the k derivative of f at 0 is minus 1 to the power of k. This is what we didn't do in the previous two examples because we just needed like the first 3 derivatives. Now we want to find all the derivatives, and all the derivatives can be written in like the last equation. That's it. We can write the Maclaurin series based on the definition of it. Just look at the definition of Taylor series. You can see e to the power of negative x is f of 0, because it's Maclaurin, x is 0, the center is 0, we have 1. Then we have the f prime at 0, which is negative 1, times x minus a. A is 0, so we have x. What is the next term? The next term is the second derivative of f at 0, which is 1, divided by 2 factorial, which is 2, times x minus a to the power of 2. A is 0, so we have x to the power of 2. Similarly, we can see that the next derivative is negative 1 divided by 3 factorial, which is 6, times x minus a to the power of 3, which is x to the power of 3. So you can keep going. If I want to write a general term, it's an infinite series. N is 0 to infinity. How can I write the general term of this? Well, it's very easy. That the k derivative is minus 1 to the power of k, or the n derivative is minus 1 to the power of n. It doesn't matter. I use this is called n. If I wrote it as k, then the power of negative 1 would have been k, divided by n factorial times x to the power of n. This is the Maclaurin series or Taylor series at x equals 0 for the function e to the power of negative x. I suggest that you look at the definition of e to the power of x and how the Taylor series is found, and see whether you can write this using the Taylor series of e to the power of x or not. You can, but see how you can do that. The next question is from the next section of the assignment. I'm going to find the Taylor series this time, so the center is not 0, it's something other than 0. So let me choose a more challenging one. For example, 27 I think is a good one. So in question 27, you are asked to find the Taylor series generated by f, and f is given as x to the power of 4 plus x to the power of 2 plus 1 at a equals negative 2. So the Taylor series generated by this f at the center, which is not 0 this time, it's not a Maclaurin series, it's a Taylor series. So think a little bit about it, see what we should do, look at the lecture note if necessary, then we are going to solve it. You can pause the video, try, and then look at the solution. Okay. So we know that Taylor series will have infinite terms, and that's usually the case. However, something interesting that you will see is that the Taylor series of polynomials do not have infinite terms, and that's not surprising because Taylor series is a polynomial, infinite terms of a polynomial with infinite terms. If the function is a polynomial itself, so the Taylor series is expected to be a polynomial too. And if the function is a polynomial of order 4, like the case here, we expect the Taylor series to be of order 4. Isn't the Taylor series exactly the same as the function here? No. Because we want the Taylor series be around a equals negative 2. So in the Taylor series of this polynomial, we will see terms like x minus a. A is negative 2, so we will see terms like x plus 2. Don't worry if you didn't understand anything from the last 1 minute of what I said. Just look what happens when we start finding the Taylor series. So now we are looking for Taylor series. We need infinite terms, but spoiler alert, we don't have infinite terms. We will have limited terms because the function is a polynomial itself. It's not like e to the power of negative x or ln of x. It's a polynomial. So the Taylor series will have only limited terms. Let's see why this happens. We have f of x given. So I just start by writing the derivative of f. It's x. Derivative of x4 is 4 times x to the power of 3. The derivative of x2 is 2x. The derivative of 1 is 0. So this is f prime. The second derivative is the derivative of the first derivative. So the derivative of 4 times x3 is 12 times x2. The derivative of 2x is 2. And let me keep going. The third derivative of f is the derivative of the second derivative. The derivative of 12x2 is 24x, and the derivative of 2 is 0. Let me write the fourth derivative. The derivative of 24x is 24. What is the fifth derivative? The fifth derivative is the derivative of 24, which is 0. And now on everything else is 0. That's why the Taylor series will have limited number of terms. We will see. So the derivative n derivative of f at x is 0 for any n which is greater than or equal to 5. Okay, we found all the derivatives. We just need to evaluate them at a equals -2. So let's start with f at -2. So f is given here. Just replace -2. We have 2 to the power of 4, which is 16. -2 to the power of 2, which is 4. We have 16 plus 4 plus 1, which is 21. So let me write the first one so that when you study you don't get confused. This is 21. What is this first derivative at -2? So we have the first derivative here. You just need to replace -2 here, and then you will see it's 4 times -2 to the power of 3 plus 2 times -2. I hope I wrote it right. -2 to the power of 3 is -8 times 4 is -32. And then 2 times -2 is -4, -32, -4 is -36. The second derivative at -2 is 12 times -2 to the power of 2 half. We're using this. So the second derivative we found at any x, we just replace x with -2, which is the center or a here. It's -2 to the power of 2 plus 2. -2 to the power of 2 is 4. 4 times 12 is 48. Plus 2, we have 50. I want to keep going. The third derivative at -2 is 24 times x. This one is very simple. X is -2. So this is -48. The fourth derivative at -2, the fourth derivative does not depend on x, it's always 24. It's 24. And the fifth derivative and all the other derivatives after at -2 are 0. Okay, we have everything we need to write the Taylor series of x4 plus x2 plus 1 at a equals to -2. That's what we were looking for. We want to write the Taylor series of this polynomial. Okay, f of -2 is 21. F prime of -2 is -36 times x minus a. X minus a is x minus minus 2, so x plus 2. The second term, the next term is the second derivative at -2, which is 50. However, this term has a division by 2 factorial, divided by 2 or 2 factorial, times x minus a, which is plus 2 to the power of 2. The next derivative is minus 48 divided by 3 factorial, which is 6 times x plus 2 to the power of 3. Is this the end? No, we have one more term. I'm going to write it down here. The last term is plus the first derivative of f at -2 is 24 divided by 4 factorial times x minus a, which is plus 2 to the power of 4. Now on, everything else is 0. So that's it. We have the Taylor series. The Taylor series in this case has limited terms. So that's always the case for polynomials. If the function is a polynomial, the Taylor series is also limited polynomial. If you want to simplify the coefficients, you can. It's not necessary. 50 over 2 factorial is 25. 48 divided by 6 is 8. And finally 4 factorial is 24, so 24 over 24 is 1. We have x plus 2 to the power of 4. Okay, these Maclaurin series that you see here are from the third slide of the lecture note on Taylor series, the one which had the picture of Taylor Swift on it. So in the next video, I'm going to discuss convergence of Taylor series and solve many questions on that. So I'm not going to get into details of that. But before doing that, I'm going to use this table, which will be given to you in the final exam, to use the convergence, to test the convergence or find the interval of convergence of another Taylor series. So look at here. Here, for example, we have 1 over 1 minus x. The Maclaurin series or Taylor series at x equals 0 is found like this, and the interval of convergence is between 1 and -1. For example, for e to the power of x, we have this Maclaurin series, and the interval of convergence is from -infinity to infinity. So we are going to solve many examples on this in the next video, practicing this, finding these intervals of convergence. Now I just want to use to solve one of the questions in the assignment 10 from the last section of that, which uses these equations to find the intervals of convergence. So just to give you some ideas, I'm going to solve, for example, question, let me see, 37. Question 37 has some functions from the above table. So it's f of x equals sine of x times ln of 1 plus x. The question is to find the 3 non-zero terms of the Maclaurin series of this function. So we want to find 3 first non-zero terms of the Maclaurin series of this new function. We have the Maclaurin series of sine in the above. You can see this is the Maclaurin series of sine, and we have the Maclaurin series of 1 ln of 1 plus x. So we need to find the 3 terms of the Maclaurin series of these multiplication. So we are going to multiply the Maclaurin series. In addition, it asks for what value, find the values of x for which the series converges absolutely. So as I said, I'm going to discuss this in more details, but now since I'm just using the Maclaurin series given above, it's very simple. So the Maclaurin series of sine of x is this is from the above table. Infinite terms minus 1 to the power of n over 2n plus 1 factorial times x to the power of 2n plus 1. This thing converges everywhere, from minus infinity to positive infinity. And the Maclaurin series of ln of 1 plus x is also given above in the table. I'm going to use it. It's infinite series from 1 to infinity minus 1 to the power of n minus 1 over n times x to the power of n. This one converges on negative 1 to 1. Okay, the Maclaurin series of the multiplication of these two, or the function given, which was sine of x times ln of 1 plus x, it's given by the multiplication of this series and this series. So you just need to multiply these two. I don't write terms, it gets very messy. I just write a few of the terms, just calculate, make sure you get what I get, which is x2 minus half of x3 plus 1/6 of x4. You can keep going. So write a few terms of this, write a few terms of this, multiply them, and you get something like this. This is the Maclaurin series of this times this. But what's more important for me is the convergence of this new one. Since this is converging between minus infinity and infinity, and this one is converging between minus 1 and 1, the new Maclaurin series, which is the multiplication of these two, converges only between minus 1 and 1, because outside of minus 1 and 1 this thing is not converging, so this is not valid. So this thing converges on the intersection of these two Maclaurin series. Therefore, the interval of convergence is -1 and 1. Thank you very much. This is the end of this lecture. I'm going to post an announcement or a new assignment explaining which questions you need to solve and submit on Maclaurin series just using what I told you in this video. Taylor series is an extremely important topic. That's why I'm spending a couple of more sessions practicing it. Having these conditions of COVID-19, I think it's very important that I practice more on Taylor series. So that's why I'm doing this. It's extremely important. You are going to need it in your next courses, so I'm not going to skip it very fast. This is an extremely important topic. Let me know if you have any questions. I'm always available in Skype, and also any other method that you can find me. So I will try to make a Collaborate Ultra room in Canvas. You can see me there too, and ask your questions. Thank you very much. Stay safe. Bye for now.